acid, bases and salts. We're starting this chapter. Acids, the word acid basically is derived from acidus. You know, acidus means sour taste. Acid's got a sour taste, like citrus, all sort of citrus fruit, sour feeling. Okay, like lemon being squeezed inside, you'll feel sour. The definition for acids is, acids are those chemicals basically which releases H positive ions in water, hydrogen ions in water. Mean acidity needs water. Okay, so more the hydrogen ions a substance releases, more acidic the character it carries. Suppose it's a marker in my hand and I put it into water, and then after taking it off I test water with a litmus solution, and the litmus indicate that it is acidic now. It means I'll say this marker has released what? Hydrogen ions. Anything that releases H positive ion is acidic. Okay, like aluminum pipes, the water passing through aluminum pipes got acidic because aluminum ions reacts with water to release H positive ions. But acids technically are the chemicals prepared in the lab or naturally occurring acids. They provide hydrogen ions, and hydrogen ions actually is basically the acidic character that it carries. That is why I said acidic strength directly proportional to the concentration of hydrogen ion. The square bracket shows concentration moles per dm cube of hydrogen ions. For easier to understand, hydrogen ions released mean acidity is there, or acidic character is there. Okay, like in our stomach, HCl, hydrochloric acid, releases H positive ions. So that hydrogen ion kill bacteria and activate some enzymes. But we want to gauge the strength of an acid, we need to find out how much hydrogen ion it releases. So that is the reason Sorensen, somebody has given a scale, because concentration of hydrogen ions can be very small and can be very varying and definitely can be misleading. So there is a scale you may not need to understand at this level, possibly out of your scope, but there is a mathematical relationship. It says pH is equal to negative log in base 10 of hydrogen ions. So calculator stuff. But by this application, or by this basically relationship, chemists are able to calculate the H positive ions. You need to know only that H positive ions can be calculated, and easier it is to represent them in the form of a scale called pH scale. And pH scale tells us the strength of an acid. You know, it ranges from 0 to 14, and lesser the pH number, stronger the acid. 0 means strongest, or below 0 can be stronger. Okay, further strong. 7 it is neutral, and then we have 14. 7 to 14 is the alkaline region of the pH. Okay, so acids basically very important industrial chemicals, highly useful, like fertilizers are made out of the acids, and many detergents and many pesticides and insecticides used in textile industry and leather industry. Okay, but a huge role of acids basically is in the fertilizers, like sulfuric acid is needed to make ammonium sulfate, and sulfuric acid is such an important industrial chemical that it is said prosperity of a nation you can gauge from the fact how much sulfuric acid they produce, because it is used almost in every industrial process. Acids are naturally occurring, we are familiar with them, like lactic acid in sour milk, or malic acid in apples. There is some sour feeling, tartaric acid in grapes, and they have usefulness in the body. Ascorbic acid, the vitamin C basically. So they have their uses, like HCl has the uses, I said it kills bacteria, harmful bacteria, okay, and also it activates enzyme and makes digestion possible, starts digestion in the stomach, because HCl somehow contributes in activating the enzyme pepsin to pepsinogen, pepsinogen to pepsin, so it breaks proteins. Okay, remember, hydrogen ions basically released by some substance, it means that is acidic in nature. Now, acids are mineral acids. We know from them their chemical formula. H2SO4 means sulfuric acid. When it is added into water, yellow oily liquid added into water, then it becomes acid, releases 2 hydrogen ions per molecule. So twice the strong as the concentration of sulfuric acid is mentioned. Twice its strength from the mentioned concentration. If it is 1 mole per liter, hydrogen ion should be 2 moles per liter. So it is deceptive. Okay, HCl, 1 mole per liter HCl mean hydrogen ions are also the same. Okay, so strength of the acid can be gauged from the fact how much hydrogen ion it releases and whether it fully ionizes, fully dissociate, completely breaks up. Okay, acids completely breaks up, and they are stronger acids. Sulfuric acid is twice as strong as it completely breaks and provide 2 moles of hydrogen ion per molecule. Okay, number of replaceable hydrogen ion it has 2, so it is also called as dibasic. Just like it is 1 hydrogen ion released per molecule, it is monobasic. This can be tribasic. Okay, but look at the change in the equation. Like it is a single-headed arrow and it's double showing on both sides. I mean these acids are weaker acids because they ionizes once and then start reversing back into unionized state. And ionized and unionized state are hung in a chemical equilibrium, and it is much tilted to the left side. Poor ionization, like 1000 particles of ethanoic acid are, when analyzed, it produces only 4 hydrogen ions. It means mostly unionized, that's why they are weaker acids. Okay, like phosphoric acid or carbonic acid, the fizzy drinks, weaker acids these are. Okay, so I said acids are the one which releases hydrogen ions. Now some chemical reactions of the acid. Look at acids reacting with metal, acid reacting with metal oxide, and acid reacting with metal carbonate. So there are different basically products, like acid with metals produces salt and hydrogen gas. Metal, active metal, not all the metals, active metals when added into this. When I said all the metals mean gold, maybe gold is inert, will not react. Copper even never react unless it is concentrated in sulfuric acid. But reactive metals will react and produce salt and hydrogen gas, and you can test the hydrogen gas. Bring a burning flame, it goes off with a pop sound. Or when it is metal oxide and acid, it produces salt and only changes, it's not hydrogen, it's water. And if it is metal carbonate, again the observation is very clear, because salt, water and the gas, but this time the gas is oozing out with quite a pomp and show, and we call that as effervescence. Okay, carbon dioxide, just like the fizzy drinks, they fizz out because of the effervescence of carbon dioxide. Hydrogen gas also oozes out, but it's not that effervescence as the carbon dioxide. So that's a test also for presence of any carbonate. Okay, or it can be test for an acid. You pour a carbonate into some liquid and it fizzes out. I mean there is actually the acidic character there, and that's an acid basically. So these are some basic reactions of acids with metals, with metal oxides and with metal carbonates. They have the salt protection, but the difference may be in the other product. Okay, so acids are basically industrially very important chemicals. They have huge uses and they have different methods of making. Sulfuric acid making we learned in contact process. Okay, and sulfuric acid is the king of chemicals, used almost in every industrial process. But acids can be stronger, can be weaker depending on the extent of ionization. And acids, if they are stronger, they must be used in dilute form mostly. If they are concentrated, they can be corrosive, they can burn the skin, we need to be careful. Weaker acids partially ionizes, they have their own uses, mostly they are edible like lactic and tartaric and malic and others. Okay, so about acids, we'll see the bases